All right, so welcome to week 9. This week we're going to be talking about web servers and cloud technologies. So we're going to be, in our labs this week, we're going to be installing the web server role and then also installing a open source blog website that we're going to make sure works. So we're just going to be going through the process of that, and then in our lecture for this week, we're going to talk about web servers and a lot of different cloud technologies and concepts. So let's get started here. So our learning objectives are to be able to describe the available cloud components, types, delivery models, and configurations. Be able to provide web services using Internet Information Services, or more commonly called IIS. Outline scenarios for implementing Windows Server 2019 in a cloud environment. So understanding the cloud. So to gain a solid understanding of cloud concepts, you have to have that to configure any sort of cloud integration in Windows Server 2019. So know how to define what the cloud is, identify the various types of cloud models, delivery models in the cloud, storage methods, because again, they're not the same as your local storage methods and delivery models and types of servers and such. And then understand the process to use to deploy new versions of web apps on cloud servers. So it's a little bit different on cloud web apps versus local on-premise web apps. So defining the cloud. So early 1990s, U.S. government-funded infrastructures were sold to create the commercial internet. So Advanced Research Projects Agency Network and National Science Foundation Network. So your internet service providers provided the internet access for a fee. Internet resources were mostly websites containing web pages with information and media. Websites are hosted on web servers, and they're accessed using either HTTP or HTTPS protocols from your web browser. So here's kind of a depiction of, the World Wide Web of the 90s and Web 1.0. So you had your web browser, goes out to your ISP, goes to your web server, which was hosted in somebody's data center somewhere. And then you can have all kinds of different images and content on there. So today's web servers contain one or more web apps. They process and communicate data and media to clients in really complex ways. Cloud server is a web server running a web app. So I think of it that way. And then cloud is the worldwide collection of cloud servers. So rapid growth of the World Wide Web in the 90s was due to free and open source Apache web server originally, which ran on the free and open source Linux operating system. And then anyone with a computer and internet access could host a web server to serve web pages without the cost of software. That's come a long way, obviously. So here's kind of, a new depiction of the 1990s World Wide Web, but in the cloud format. So you see here that, really we've just replaced our data center with the cloud, essentially. So it's still running a website. It's still on a server somewhere. However, you don't really manage that server anymore. So in the cloud, a lot of use is based on web app frameworks. So, which that is a collection of software packages or modules. Software developers can write web apps using a particular programming language, and there's no need to implement any underlying system functionalities, right? So they don't need to worry about what's configured on the system because it's part of the package. Examples are the Django web app framework, which uses Python. If any of you have taken the Python class so far, you probably are familiar with the Django. It's probably the most common framework for Python. And then Microsoft.NET Web App Framework uses different programming languages. So this is a little bit outdated, but C# and Active Server Pages. Nobody really uses Active Server Pages anymore. C# is pretty much the de facto standard for .NET at this point, for both web apps and forms-based apps. So what are the cloud types? So your cloud provider hosts your cloud servers. So a public cloud, you could think of Google, Azure, AWS. Those are cloud servers that are on the internet that can be rented by others. Your private cloud is going to be cloud servers used exclusively by the organization that owns them. So you buy the hardware. However, everything is accessed through the internet. It is not on your local network. And then hybrid cloud uses both a public and private cloud together for a specific purpose. So there's a couple different delivery models for the cloud. And this mainly has to deal with web applications. So these are the methods that are used to host web applications on a cloud server. So you have infrastructure as a service, which this is basically, you're spinning up a virtual machine in the cloud, and you're configuring all of the application settings and installing the application on that virtual machine in the cloud. Platform as a service, you lose control of being able to do configurations and such on the virtual machines. It's more of a platform, whereas you have access to a certain type of software. And the platform as a service and software as a service are really closely mirrored to one another. So software as a service, you go to a website, you don't worry about anything underlying, like how it's hosted, anything like that. That is all taken care of for you by the provider. So that is the main difference between platform as a service and software as a service, and then infrastructure as a service. The platform as a service and software as a service, someone else is handling that configuration and management part of the virtual infrastructure that is running those applications, versus platform as a service and software as a service is, or opposed to infrastructure as a service, where you are actually managing and configuring that virtual machine in the cloud. So here's kind of our sample of your infrastructure as a service. You can see here that the cloud provider handles the hypervisor, the server hardware, the network access, all of that. All you're concerned about is the operating system and whatever's installed on it, whether it's a web app or, could be DNS, could be Active Directory, could be anything. But you're only concerned about what's on the virtual machine. You don't have any concern or any oversight over the hypervisor or hardware or network or anything like that. A platform as a service is a little bit different. It runs more on a containerized architecture, where you have your web apps run a container, and then your cloud provider is maintaining the container software and anything, the operating system, hardware, and network underneath of that. So you can see here, as you can spin up different containers, but you have no control over the virtual machine that is running this, essentially. And then software as a service, basically it's not containerized. It probably is containerized in the background, but you have no control over the container. You're just getting the web URL, and that's all you get. And you have no access to any of the underlying systems that are behind it, like the container or anything like that. And you can see that the main difference here is there's no container. And then the operating system, hardware, and network access are managed by your cloud provider. So cloud storage, web apps store large amounts of data on a cloud provider. So there's a couple different options. There's block storage, which stores data on a file system. This is charged based on the total amount of storage that your files are using. It's fast and often used for storing database files. And then it's associated with a single web app, virtual machine, or container only. Object storage is slower than your block storage and less expensive. Web apps directly store objects using HTTP requests to send objects into the storage service. This is easily shared between different web apps, virtual machines, and containers. So it's important to note that block storage is pretty much tied to the web app, virtual machine, or container that you're in, versus object storage is more of a shared type storage. So one of the benefits of moving to the cloud is having that continuous deployment strategy for all of your software applications. So what does continuous deployment mean? Basically it means that updates are pushed down when they're released versus, you having to run those updates. It's going to update it automatically. So web apps are created by developers in an organization. They get hosted out in a container or a virtual machine, and then it's revised continually to fix bugs and add new features. And then it's created on a desktop and tested on the cloud provider. Continuous deployment workflow process runs as you create a new container or VM using build automation software. You move the web app to a new container or virtual machine on the cloud provider, and then you ensure the web app is ready for execution, and then the server administrators manage that process for your dev operations. So continuous deployment is more about streamlining the update process for whatever application is running. So here you can see, here's a good depiction of your continuous deployment. You can see that we have a developer workstation, which is pushing updates to a code repository, which is then pushing updates to an orchestration server, which is then pushing that updated software to a build automation server, which is automatically building out a new container to push out the new version of that web app out to the customer. So that's all about the cloud. So now we're going to talk about configuring web services. So Microsoft's Internet Information Services is the web server software that runs on Windows Server 2019. It's used to host websites and web applications. Examples of web apps where IIS is automatically installed and configured is Remote Desktop Web Access, Windows Admin Center, which we did earlier, Internet Printing Protocol Web App. So there's a bunch of third-party web apps that may require IIS installation, like help desks, blog websites, which is what we're going to do in our lab this week. And then web apps used to sell products or provide service. There's pretty much anything, any app that you use now is pretty much web-based. So there's not a lot of apps anymore that are local forms or like Windows applications, other than some of your standard like Office type stuff like that. So web apps adhering to the Common Gateway Interface or CGI standard can interface with IIS, and then web apps supporting the IIS API can use a group of generated dynamic link libraries to provide closer interaction with IIS and better performance. And what does this mean? This means that basically you can run some of the Linux-based programming languages like Python, PHP, some of those type of applications on IIS now. You didn't used to be able to do that. However, the de facto standard for running on IIS is still ASP.NET, which you could see down here at the bottom. You use ASP or ASP.NET web app frameworks on IIS mostly. Not a lot of people run PHP and stuff like that on IIS. It's mostly an Apache thing, but you can do it if you want to. Microsoft provides additional IIS features for ASP.NET web apps, which is mostly the application pools for security and management, which we'll get into in our labs. Web server access is required by the developers usually. That's important to note if you work anywhere that develops software. They are going to need to test that on the on a web server. You can't test everything locally. So your web server location, if you have an organization, it allows shared folders using SMB or NFS to provide access to your developers. For a cloud environment, usually you got to use FTP to transfer website and content up to that. IIS does contain an FTP server service to provide FTP access. We're not going to go into that in this lab this week, but you can set that up. And then WebDAV is used to upload and modify website content, not the web app content. So it uses standard HTTP and HTTPS protocols to transfer information. So this would be to put up like pictures, stuff like that is what WebDAV is used for. So how do we install IIS? So like every other feature that we've done so far, you do it through the Add Roles and Features wizard. You select Web Server IIS role, and then you progress through the wizard. You choose the necessary IIS role services subcomponents, and then the Add Roles and Features wizard is also used to add additional role services, like say you need to add a service after you've already done the Roles and Features wizard for IIS. You can do it again and just add what you need. So like say you forgot to do if you forgot to provide HTTP redirection, you can then go back and rerun the wizard and add that feature. So here's kind of a table of all the role services. So I'm not going to go through each one, but you can see there's common features, health and diagnostics, performance, security, application development, FTP, and then management tools. So here's kind of what that looks like when you go to the role services. So you can see you have your web server, and then you have, that corresponds with what we just looked at in the table. And then once you want to add to an existing installation, you can see that stuff's already checked off here. So you can always come back and check additional features off. So the IIS Manager tool is what you use to manage the web server and website configurations after IIS is installed. So you start the IIS Manager just like everything else from the Tools menu in Server Manager, or you can also get to it from the Administrative Tools area. So one thing that does get created by default is the default website. So it's created by default under the sites. It responds to HTTP requests on TCP port 80. This is not good, so you'll want to change that immediately when you spin up a new server and install IIS. Usually I change it to like 9999, because generally when you install any piece of software, you're going to create a new, or whenever you install a web application, you're going to create a new site for that. And then your website and web app content goes in the folder C inetpub www. That is where all of your folders that correspond to your websites will be. So if you have 15 websites on there, you're going to have 15 folders underneath the www root. And then also, if you go back one level under inetpub, there is a logs folder, which you can get to the logs for each of those websites through there. So here's what the IIS manager looks like. You can see in the middle here we have all of the settings for this specific website. And as you click on tree nodes here, you get different settings in the middle. You can see we have the default website, and then it's got some folders under it, and then it's got this icon is a virtual application. So there's a couple different ways to publish applications. You can either do a virtual application underneath of a website, or you can do a website that points to a specific folder. Just depends on the application and what you're doing there. So users access the website and web app files through the CINetPub www root folder. The user must authenticate to the web server, and then access depends on the NTFS permissions assigned to their user account. So to allow public anonymous access to the default website, you have to go into the groups on that server, or you could do it in the Active Directory domain and go into the IIS iUsers group, and then that needs to have read and execute and list folder contents on that www root folder. Now, a lot of this is done by default for you, so you don't really have to do this, but that's how it works. So if you want to access the properties of that CINetPub www root folder, you right click on it, go to properties, and then you click edit permissions, and then you highlight the security tab to modify the permissions, just like we did with other folders before. Obviously, opening the folder, you can just go to that path, and then you can optionally configure the default website to respond to HTTP requests if you have an HTTPS encryption certificate. So how this is done is you go under bindings, and then you go add the HTTPS protocol, or you can change the port to something different if you don't want it to be 80. And this is how you do that there. When you go into the site bindings, this is where you will see it's responding on port 80 and port 443 under HTTPS. So this, for the default website, I normally change this one to like 9999 or 88888, something that is not port 80. So the features view pane displays the default website features. This is what I was talking about earlier. You can configure features for each IIS role service subcomponent. So you'll have a bunch of features inside of each subcomponent, and then you select it in the features view and click open feature from the actions pane. So website content is used to access the web apps, so not normally stored in the inetpub www root folder of the default website. Server administrators create a virtual directory under the default website for each web app on the web server. Like I said, you can do that, or you can create a new website. Either way, it doesn't matter. You just can't have two websites running on the same port. So you can't have two websites that are bound to port 80. Otherwise, you'll get an error, because obviously it's listening on that port, so it can't do both at the same time. And then virtual directories associate a directory name to a folder in the file system containing the website or web app content. So that's what I was looking at earlier, where I said there's a virtual directory. So you can either publish as a website, or you can copy the content to a folder underneath the default website and make it a virtual directory. Either way, it will work. And here's your common IIS configuration features. So you have authentication, compression, your default document, which is important because that's what it will automatically go to if someone just types in serverx.yourdomain.com and doesn't put in like iisstart.htm or default.aspx, it needs to have a default document that it will go to. Directory browsing, and then error pages. So here's some more. You have handler mappings, IP address and domain restrictions, logging, request filtering, server certificates. This is an important one. So if you're running a SSL website on here, that's where you'll upload your certificates. And then SSL settings is where you can require SSL for a specific website. So here's how you add a virtual directory. So you can see here we're adding it to the default website. We're giving it an alias of xcontrol, and then here they're putting the physical path as the C drive. I would never do that, but that's where you can do that. You can also change the connect as, so that it connects as a domain user versus the application pool, things like that. So hosting web apps in a public cloud. So if you're going to run a Windows web app in a public cloud using SaaS, the public cloud provider configures and maintains all aspects of the underlying Windows operating system. It might not even be Windows underlying. The organization provides the web app and configures block and object storage. Then continuous deployment needed if web app created by organization. So if you create the application, you need to do the continuous deployment for that. And then the public cloud providers provide this software in a SaaS configuration file for a fee. So if you're running a web app in a public cloud using infrastructure as a service, so your organization is going to create, configure, and maintain the associated server virtual machine on the public cloud provider's hypervisor. So you don't have to worry about the storage underlying or anything like that. You just install the small footprint virtual machine due to resource charges. That's important to note that you keep it as small as possible because you are going to be charged hourly for that. If web apps use object storage exclusively, you purchase enough block storage to support the needs of the virtual machines. Most public cloud providers offer a large selection of virtual machine templates, making the process of creating a new virtual machine easier. And then they provide continuous deployment using orchestration software or configure additional virtual machines or containers that run the software. And then configuring using a SaaS cloud delivery model. You install Windows Server 2019 on a physical server dedicated for running the web apps. The physical server must contain adequate hardware resources and storage to support the web apps. And then private clouds typically use block storage exclusively because SANs and other storage technologies provide fast, scalable, fault-tolerant block storage to cloud servers. And then if you want to run a large number of virtual machines in a private cloud using the infrastructure as a service, you'll want to use the Windows Server 2019 Data Center Edition or Hyper-V server. You'll want to configure the virtual machines to host Windows web apps and Linux web apps using WSL. Create Linux virtual machines on Hyper-V to host Linux web apps. And then you can create Hyper-V virtual machine templates for easy deployment, which we did kind of talk about earlier in week 3, I believe. And then you can create Hyper-V virtual machine templates containing a Linux distribution as well as Windows. And then you can actually include the web server software and web app framework inside of those templates. So you can build out a template that has everything already in it that you can just push out on demand. So in summary, we have the cloud represents a worldwide collection of cloud servers that host web apps. Organizations hosting cloud servers are called cloud providers. Web apps can use block or object storage. And then IS web server on Windows Server 2019 provides for websites and web apps to host them. So that's it for our lecture for this week. You can move on to Lab 9.1.